Hello there, and I'm an old guy and I do maths. Today we're going to have a look at linear functions and graphs, and we're going to go through the whole thing. There's quite a bit of content in this. Feel free to watch just little parts of this. You'll find that on my channel that there are a number of shorter videos which break up the various parts of this, but I thought it would be useful to just go through from beginning to end and show how we take a linear function in this form, and this is the linear function we're going to use, and graph all of the necessary parts of it. Okay, so let's get started. So a typical linear equation or function, they can be called either, as far as I'm concerned, just in everyday use, is in the form of y equals mx plus c, where m is our gradient and c is the y-intercept. We'll come and have a closer look at what those two things mean in a moment. Okay, so m is gradient, c is y-intercept. So looking at this equation, the gradient of this line is 2, because that's the number beside the x, and the y-intercept of this line will be 1. When this equation generates the points that we need to draw a line, the y-intercept will be 1. Same as here. This simply means y as well, and it's called function of x. Okay, so if we put these into a table which you might have seen at school, we take a number, and I've just decided to go from -2 to 2. We take a number and we put it into this equation. So what happens? Where the x is, we put -2. So that means 2 times -2, which is -4, plus 1 gives us 3. 2 times -1 is -2, plus 1 gives us -1. 2 times 0 plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. And what this has generated is a series of ordered pairs. Here's an example of one. Our x-coordinate here, 1, and our y-coordinate here, 3. And I've plotted this on my roughly drawn Cartesian plane, very roughly drawn. And I've also plotted the y-intercept, which is when x equals 0, we got 1. And so you can already see where this line is going, roughly. It's going to look like that when we draw it in. So let's get to that. And here we are with the same equation and the same table. And what I've done is I've taken each of the points from this table and I've plotted them. And you can see that they line up reasonably neatly. And just a reminder here, the -2 is the x-coordinate, the -3 is the y-coordinate. So to find that, we go -2 along the x-axis and down 3 on the y-axis. And here it all is joined up. That's our line, positive gradient, bottom left to top right. The value of the gradient is 2, and there's a whole separate video on how you actually find that. So have a look at that if you're having a little bit of trouble with this. And the y-intercept is 1. So that number there gives us the gradient, that number there gives us the y-intercept. Okay. So, just to drive it home, our y-intercept here is really easy to find because it's 1. It's on the end of the equation. But occasionally, things can be a little more confusing. Now, I'll just put my pen across my working there. And what we have here is we have an equation, -3y equals 6x minus 12. Now, you can see that this is not in this form. It's got a -3 in front of the y, and we need to get rid of that so that our equation will look something like this. And here's how we do it. We divide each side by -3, and what that does is it gets rid of the -3 here. So negative 3 divided by negative 3 is 1. And we divide the right-hand side by 3. So that, I hope, is fairly clear. If it's not, have a look at my video on rearranging linear equations, where you'll see examples like this worked out. What we're looking for is we're looking for an equation in this form. And by the time we've done a little bit of working here, this is what we get. 6x divided by negative 3 gives me negative 2x. Negative 12 divided by negative 3 we see here. And when we work that out, we get 4. And now we have this in the form in which we want it. Y equals negative 2x plus 4. 4 is our y-intercept. We have found the y-intercept. The gradient of this thing is negative 2. We'll get to that in a minute. Okay, so sometimes you might see this written like this. It's considered more stylish, but it's essentially the same thing. The number on its own is the y-intercept. The number here is the gradient. The gradient is negative 2, the y-intercept is 4. There we are. Okay, how do we find the x-intercept? That's this thing here. And just to spoil the surprise, I'll tell you that it's negative 1/2, 0. So how do we do that? How do we find that? It's relatively simple. You make y equals 0. Oh, what does that mean? Well, what it means is that you take this equation, and where the y is, you put 0. And then you go to work to find x. Okay, so let's do that. 0 equals 2x plus 1. Now, I like to write it the other way around. I like to work from left to right. And the first thing I do is I subtract 1 from each side so that this 1 disappears. And what I get is I get 2x equals negative 1. And the next thing I want to do is I want to get rid of the 2. So you'll see here that in very faint writing, I've divided 2 by 2 and negative 1 by 2. I've divided each side by 2. And what I wind up with is x equals negative 1/2. So the x-intercept for this equation, which you are hopefully familiar with now, is negative 1/2, 0. So what have we found? Well, we found the gradient, which was 2. We found the y-intercept, which was 1. We've found the x-intercept, which was negative 1/2, 0. And that is everything that you need to draw this line from this equation. I hope you found this useful, and I'll see you on the next video. Thanks. Bye-bye.